Okay, homework 1, problem number 2, physics 2. So let's write our knowns. Q1, Q2, Q3, and Q4. We know all of these equal something. Q1 equals negative Q2, so we're going to have 275 times 10. This is going to be negative 275 times 10. This one's going to be 270. This one's going to be negative 270. And these are going to be all times 10 to the negative. I think this is going to be negative 6. Could be negative 9th. It's micro. This one's so 1. Yeah, it looks like it's 9th. And then we have A. A is the distance, and that's going to be 0.035 meters. Okay. So let's start doing really cool drawings. So 1 is positive, 2 is negative, 3 is positive, and 4 is negative. So this is going to be testing, let's see, like where does a particle flow? Does it flow positive, negative, or negative to positive? So to me, let's see. Okay, this is just, no, not even. Attraction or repel. Okay? Here, we have two like charges. So these are going to repel. Here, these will attract. These will repel. And then these will attract. Well, now let's see, what are they asking? Right? They're asking, what's the component? So they're asking about particle 3. This is the particle we need to be looking at. What's the x component of the net electrostatic force on the particle? Okay, so the net force. What we now have here is we are just going to look at everything that's happening here. So we're finding that on 3, this one here that we're looking at, it's going to be repelled by 1. Okay, so it's going to be pushed away. For 4, it's going to be attracted, so it's going to be pulled. And it's also going to be attracted to particle 2. So those are the 3 particles acting on it. These are the 3 forces. We can call this like F3, F4. No, I'll call it F2, F4, and then F1. Okay. So now with these, let's do, well, this is going to be the Coulomb's law thing, so actually we can call this F1,3, F4,3, and F2,3 to be even more exact. So now let's write F. Let's do F1,3. And then let's find F4,3. And then lastly, let's find F2,3. And remember that the law here for the Coulomb's law, it's going to be F equals K. And then it's going to be Q absolute value Q1 Q2 R squared. Okay? So with this one, let's say that also we need to know that K equals 8.99 times 10 to the ninth. So here we can write 8.99 times 10 to the ninth. And I will do these square brackets just because it's easier for me to write that. Might have to be a little bit longer. Okay. We're going to have particle 1 and particle 3. That's interesting. Since it's an absolute value, the force is going to be the same. It's just the direction that changes if it's positive or negative, I guess. Let's see. I could be completely wrong about everything. So Q1 and 3 can be 275 times 10 to the negative ninth times Q3 is going to be 270 times 10 to the negative ninth, and this is going to be all over 0.035. Squared. Which that's going to give us an answer of, well, start plugging things in. Okay, looks like I'm getting 0.5449. Take it to this many significant figures just now, and I think this is going to be in newtons. Okay, and just write it a little bit low. This here is going to be 8.99 times 10 to the ninth. And it's going to be Q2, no, Q4. 270, and then Q3 is also going to be 270. Okay, this one's going to be 0.5349. So very similar. And then 2,3 is going to be interesting because it's at an angle here. We're going to have a side here of A, a side here of A, and what would this be? 2 square root A? For the top here? I'm not sure. Let's see, A squared plus B squared equals C squared. So this would be C squared plus B squared equals C squared. Yeah, okay. So then if I have No, I don't think that's right. I don't know where I got that from. So what we could just say is this is going to be, is this square root 2a? A squared plus a squared equals c squared. That would be, I don't know, 0.35 times 0.35 squared plus 0.35, 0.035 squared. Then we can square root that. Okay, so we're gonna get a value here of, I'm gonna call it c or something, I don't know. And I'm getting a squared, a squared. I'm getting 0.04949. Okay. So here we're going to have 8.99 times 10 to the ninth and this is going to be 2 and 3. So the same as this. Now this is going to be split into two forces. This is going to be the magnitude of the force. We're going to have an x value and a y value for this. And the x value is going to be 0.5449. Well, we could just say this is going to be sine of 45, can't we? This should be a 45-degree angle. Yeah? And then this should be 5449 cosine 45. That's just an easier way of doing this. This is going to be 0.385, and then the cosine, it should be the same thing. I think sine and cosine are the same thing. Yeah. 0.385. We can add a 3. Okay. Now, f13 is completely in the y. So we can say this one's y, and this one's completely in the x. So now let's add our x's and y's. So we're going to have uh, 5.349 plus this, and a 0.5449 plus this. So for the y, we're going to get a negative, because it's in the down direction here. Well, actually, that's interesting. They're going to have to be subtracted. Let's look at the directions. This is very funny. We've got a positive y here and a negative y here. So these actually will cancel out. So let's do 2, 3, which is here, and let's subtract this. So we're actually going to have 0.38, and we're going to subtract a 0.544. Maybe the other way around. Doesn't. Dang. Ah, yes, I completely forgot. Okay, this is the problem. This is not 0.035. I don't know why I wrote that. I even solved for it here. It's this here. So this is actually 0.04949 squared. This should solve all of the world's problems. Okay, now we're going to take that and we're going to here we go. This is going to be 0.2675. Perfect. Now sine of 45 is going to be, say this goes straight down, it can be 0.189. Let's say 2, why not? Okay, now we're going to have the y component here, f13. We're going to subtract that. Or, sorry, this, and we're going to subtract 1, 3. So we're going to take this, we're going to subtract 0.5449. Okay, the y component here is going to be negative 0.355. Or 353. And the x component here is going to be adding. So we're going to add the 0.53 plus the 0.18, and we are getting 0.728. Okay, there you go. That is how you do problem 2. Apologize for misleading for the second I did.